Welcome to Brain Injury Diagnosis Made Simple. Diagnosis Made Simple. Concussion injuries are functional, not structural injuries. A concussion occurs when kinetic energy is transferred to the head. According to BCMG Medical Journal, brain injury can be shown when the tissue changes metabolism. This is something that Qeegs can measure through the electrical activity of the brain. Whiplash-induced concussions result due to this disruption of electrical signals, and this cannot be shown currently on MRI, CT, SPECT scan, or PET scans. And this is well known, it's just typically not assessed for. According to medical textbooks, damage to the brainstem, the reticular formation, that can occur in whiplash results in symptoms such as difficulty focusing, poorly regulated sleep-wake cycles, and weak alpha waves, which we'll get to. So basically, damage can hurt the brainstem, which then affects the electrical current through the brain. Now, there's several methods to test for this. In the UK currently, they're using something called a regional cerebral blood flow scan, which is this test here. Now, we don't have this in Canada, but what we do have is a Qeeg, which measures the electrical activity of the brain and then uses mathematical equations to show injury potential. And this test has been shown to be 96.59% sensitive in diagnosing concussion. So if we look at an EEG, with an EEG, we have several different waveforms. Delta waves are typically when you're sleeping. Theta is a state of drowsiness or meditation. Alpha waves are when you're resting but not really doing any activity or thinking about anything. Beta waves are when you're trying to focus, concentrate, or determine a problem, an answer to a problem. And gamma waves are when that problem is a much more difficult problem. Post-concussion syndrome appears associated with alterations of the resting state or default network of the brain. So that's with alpha waves. So everything you think, feel, or do is electrical. So we can evaluate your brain in real time by measuring these electrical impulses. EEG, which measures the electrical activity of the brain, puts it through an interface in a computer program that does a mathematical equation to determine the microvolts in each region of the brain. So this is an example of a healthy brain, and this would be an example of a dysfunctional brain. Application of the Qeeg will give us two power ratios. The first is a stress capacity ratio, and the second is a focus capacity ratio. This shows us the amount of stress the person is under and how they are able to cope with that stress, and it also shows us their ability to focus. Power ratios, we are given construct scores that show a person's activation baseline, max activation baseline, stress regulation, focus capacity, focus endurance, and impulse control. We're also provided with information about response times and variables, and how many errors the person made during the testing. We're provided with amplitude, or the electrical activity of the brain in microvolts. So we're provided with several different waveforms, delta, theta, alpha, beta, and it goes into gamma. And there are also several tests that are performed. So the first one is an eye closed test, which gives us a baseline of these waves. Then we go into a low stress task, a second low stress task, a high stress task, a second high stress task, and then finally one more low stress task. So we're able to see how the brain is reacting and functioning in real time. We can put it all together to show how a Qeeg can determine injury, specifically concussion, from a motor vehicle accident. These are three different scans, and they're measuring the amplitude values, which is in microvolts. If we look at the resting state of the brain, alpha, with eyes closed, this is our baseline test. This person, a PZ sensor, that's the back of the head, has an alpha rate of 130 microvolts. When they open their eyes, it drops to 8 microvolts. This is a normal finding. This is what we would expect to see in someone that is not injured. Same thing with this assessment. The PZ sensor shows 131 microvolts, and with the eyes open, 34 microvolts. Now that's just a tad bit high, but it's still within normal range. Now if we go to this third test, we'll see the PZ sensor is only 19 microvolts. This is extremely low for eyes closed, resting brain activity. When they open their eyes, it drops to 6 microvolts. So this is indicative of a concussion associated with a whiplash injury mechanism or motor vehicle trauma. Now this research regarding QEEGs and concussion, there's over 460 articles that were reviewed between 1996 and 2016. And they found while conventional EEGs were not useful in diagnosing concussion, QEEG showed immediate reduction in the mean alpha frequency, which I just showed you. And this is also supported by the admissibility of QEEG through the Supreme Court in 1993. It passed the DeBart criteria. So this is the most accurate and reliable assessment for concussions on the market today. In comparison, SPECT scans only provide a 54% sensitivity for mild traumatic brain injury, MRIs are only 9%, and CTs are only 4 to 6%. So that's a very significant difference in sensitivity. So what can we evaluate using QEEG? We can evaluate for head trauma, mild traumatic brain injury, blood-brain barrier disruptions, white or gray matter disruptions, post-concussion syndrome, general cognitive processing ability, stress reactions, cerebral metabolism, fibromyalgia, depression, anxiety, chronic pain, and chronic fatigue. We can determine all of these things through the different brainwave activity and different brainwave responses determined through the QEEG. This is a real-time neurophysiological imaging study that provides accurate and reliable test results to determine concussion post-motor vehicle collision.